Welcome, everyone, ready to dive into some serious cosmic power.
Always ready for that.
Today, we're going deep into the universe's most extreme energy events. We're talking about forces that make supernovae look like, well, like nothing.
Yeah, it's hard to even grasp the scale sometimes.
Absolutely. Our guides on this journey are Neil deGrasse Tyson, Chuck Nice, and astrophysicist Tim Pagan. So have you ever wondered what could possibly cause such powerful events?
Buckle up, it's a wild ride.
Let's find out.
Okay, to start, let's actually begin with something we all know. Light.
Okay, I'm with you. Light is energy, right?
Right. But there's light, and then there are gamma rays.
Okay.
We're talking the most energetic form of light, way beyond X-rays. And these gamma rays, they come from the most intense, most violent events the universe could throw at us.
So, like, what kind of events are we talking about here?
Imagine a black hole, right? Just spewing out matter, but at almost the speed of light. Or a giant star collapsing in on itself. Or even, get this, neutron stars smashing together. Yeah, it's intense. And these events are so powerful, they actually generate these gamma rays. It's insane.
That's amazing. But hold on, if these gamma rays are so powerful, why aren't we, like, fried all the time?
Good question. And luckily for us, gamma rays can't get through Earth's atmosphere. It acts like a shield.
Phew.
Yeah, but it also means to actually study these gamma rays, we need special telescopes up in space. Can't do it from down here.
Makes sense. Okay, so we're good on the gamma ray front. But what about cosmic rays? I hear about those all the time. What exactly are they?
All right, so here's the thing about cosmic rays. They're not really rays at all. They're particles, mostly protons, zipping around at crazy speeds, almost the speed of light.
So fast.
Yeah, and get this. Thousands of these particles, called muons, are passing through you, me, everyone, every second.
Wait, seriously?
Yeah, it's wild, right? They're created when cosmic rays hit our atmosphere.
So we're basically swimming in this invisible energy.
You got it. And the source of this energy, well, it's those same crazy events that make gamma rays. You got your supernovae, your active black holes. They generate these massive shock waves that act like giant cosmic accelerators, sending these particles flying across the universe.
So shock waves are kind of a big deal, huh?
Huge deal. Think of it like an explosion, and one that moves faster than the speed of sound in space.
Whoa.
Yeah, they accelerate particles, trigger those supernovae we talked about, and of course create cosmic rays. Basically, shock waves are how energy moves and changes in the universe.
Okay, let's talk more about supernovae for a second. I always get a bit confused about the different types of explosions. So what's the difference between, say, a nova, a supernova, and a hypernova?
Think of it like a scale of energy. A nova is like a sudden burst from a white dwarf star, often one that's part of a binary system, bright but not, universe-ending.
So if a nova is like a firecracker, what's a supernova?
If a nova is a firecracker, a supernova is a full-blown nuclear explosion. We're talking the complete destruction of a massive star, releasing more energy in an instant than our sun will in its entire lifetime. I mean, a supernova can outshine a whole galaxy. It's nuts.
Insane. And hypernovae, those are even more powerful.
Hypernovae, those are like supernovae but turned up to 11. We still don't totally understand them. The physics is just mind-blowing. It's like the universe is saying, look what I can do.
All right, so we've got these super powerful supernovae, but are there even more energetic explosions out there?
You bet there are. Let me introduce you to gamma ray bursts, or GRBs. These are, without a doubt, the most powerful explosions we've ever seen in the universe. I mean, they make supernovae look like tiny little sparks.
Wow. Okay, what causes one of those? A gamma ray burst, I mean.
Well, the main theory is that they come from the collapse of some of the most massive stars out there. Or maybe when two neutron stars spiral into each other and collide.
And how do we even detect these bursts? They sound pretty quick.
We rely on the Fermi Gamma Ray Space Telescope. It's constantly scanning the skies, looking for these super brief but intensely bright flashes of gamma rays.
Sounds like we still have a lot to learn about these events, huh?
Oh, tons. For example, we've seen both short and long gamma ray bursts. The short ones are over in milliseconds, while the long ones can go on for minutes. Figuring out why there's that difference and how long they last, that's one of the big mysteries with GRBs.
That's fascinating. It's amazing to think we're just starting to understand these incredible events.
It really is, and there's so much more to uncover.
Well, before we get to the rest, let's switch gears a bit and explore another consequence of these extreme energy events, pulsars.
Ah, pulsars, the lighthouses of the cosmos. Spinning super fast and sending out beams of radiation like clockwork.
But what are they exactly?
Picture this. You take the entire mass of the sun, right, and you squeeze it down into something the size of, I don't know, a small city. That's how dense a neutron star is. And a pulsar. It's a type of neutron star, but it spins incredibly fast, sometimes thousands of times per second.
Whoa, that's mind-blowing. And how do they make those radiation beams?
It's all about their crazy strong magnetic fields. Those fields, plus the insane spinning, it creates these powerful electric fields that basically launch particles out at nearly the speed of light. and that's what guides the beams we see.
So we've talked about gamma rays, cosmic rays, supernovae, and now pulsars. It's amazing to think that they're all connected in some way.
Totally. They're all linked by these fundamental forces in the universe and the crazy amounts of energy they release. But remember, these cosmic rays, these high-energy particles, they're not just putting on a light show. They actually shape the universe itself.
Okay, now I'm really intrigued. How do these particles actually influence things on a cosmic scale?
Well, think about all those clouds of gas and dust you see in galaxies. Those are like stellar nurseries where new stars are born. Cosmic rays can heat up that gas, which changes how and where those stars form.
So they can actually trigger star formation.
Exactly. But they can also do the opposite. By ionizing those same clouds, they can stop star formation from happening in certain areas. It's a delicate balance between creating and destroying.
Wow, so it sounds like cosmic rays are more than just byproducts of these extreme events. They're active players in how galaxies evolve over time.
Exactly. They're constantly interacting with everything out there, shaping the structure of galaxies over billions of years. And speaking of shaping galaxies, we can't forget about how our own solar system got here.
You're right. It's easy to get caught up in these big, powerful events and forget about our own little corner of the universe. So tell me, what's so special about how our sun formed?
Our sun has a pretty cool backstory, actually. It's not a first-generation star, born from the very beginning of the universe. It's actually a second-generation star.
What does that mean, second generation?
It means our sun formed from the leftover stuff from earlier supernovae. Think about that for a second. The heavier elements in our solar system, like the carbon in our bodies, the oxygen we breathe, even the silicon in our computers, it was all made in the core of long-dead stars.
Wow, so we really are made of stardust. That's an incredible thought, and it really ties everything we've talked about together.
It does, doesn't it?
It's been an amazing journey so far, and I can't wait to delve even deeper into these mysteries.
It really is humbling, when you think about just how powerful, how huge these events are. Really puts our everyday worries into perspective.
It really does. Like, we're all stressed about deadlines or traffic or whatever, and out there, stars are exploding, black holes are smashing into each other. It's just a whole other level.
Totally. It reminds you that there's so much more to the universe than just us.
Yeah, and it's amazing to me how connected it all is. We started with just light, and now we've talked about gamma rays, cosmic rays, shock waves, supernovae, even how our own sun formed. It's all linked together.
That's what I love about astrophysics. It's like this giant puzzle, and every new thing we discover helps us see the bigger picture.
Speaking of discoveries, what are some of the big questions that astrophysicists are still trying to figure out? What mysteries are still out there waiting to be solved?
Oh, man, so many. Like, take gamma ray bursts, for example. We know they're incredibly powerful, but we're still not sure exactly how they release so much energy so fast. The physics is it's really complex.
And we talked a bit about hypernovae earlier. Those seem to really push the limits of how we understand stars exploding.
Yeah. The energy there is so extreme, it really challenges our current models. Like, we might need to rethink some of our ideas about gravity or even fundamental physics to really understand how those work.
And of course, there's the whole mystery of dark matter and dark energy, right? These mysterious forces that seem to make up most of the universe.
Right. Dark matter and dark energy. Still big enigmas. But they're probably playing a huge role in how the universe evolves, including all these extreme events we've been talking about.
It seems like with astrophysics, every time you answer one question, you just end up with a dozen more. Never a dull moment.
Exactly. Always a new mystery to solve, a new discovery waiting to be made.
So for those of us who aren't astrophysicists but are totally fascinated by this stuff, where should we go to learn more? What are some good resources out there?
Oh, there are tons of great resources. Like, Carl Sagan's Cosmos is a classic. And A Brief History of Time by Stephen Hawking, that's another great one.
Those are both on my bookshelf. For something a bit more recent, I'd recommend Astrophysics for People in a Hurry by Neil deGrasse Tyson. It's a really good, quick overview of some key ideas.
Oh, yeah, that's a good one. And don't forget about all the stuff online. NASA's website is amazing, and there are tons of online courses you can take if you want to dive deeper into specific topics.
So looking ahead, what are some of the most exciting areas of research in astrophysics? What do you think we'll see in the next decade or two?
One area I'm really excited about is gravitational waves. Those ripples in space-time that were first detected back in 2015.
Yeah.
It's like a whole new sense, a whole new way of observing the universe.
We're not just seeing the universe anymore, we're listening to it too.
Exactly. And as we build more sensitive detectors, we'll be able to hear even fainter gravitational waves. It'll give us a glimpse into things like black hole mergers, maybe even back at the very beginning of the universe.
Whoa, that's incredible. Anything else on the horizon?
The search for exoplanets is still huge. We've already found thousands of planets orbiting other stars. And some of them might actually be able to support life.
Imagine if we actually found evidence of life out there. It would completely change how we see ourselves, our place in the universe.
Oh yeah, it would be a game changer for sure. And as our technology gets better, we'll be able to study those exoplanets in more detail. Look for things like atmospheres, water, maybe even signs of life itself.
It's mind-blowing to think about all the discoveries that are still out there just waiting to be made. It's a really exciting time for astrophysics.
It really is. Who knows what we'll find next? The universe is full of surprises. I think we've only scratched the surface.
I can't wait to see what the future holds. But for now, let's bring it back to that stardust we're all made of.
Sounds good. What are we thinking about?
Well, we talked about how those elements were created in supernovae, but I'm curious about the bigger picture. If we're all made of stardust, does that mean we're all connected on some fundamental level? It is pretty profound, isn't it, when you think about it? Like, the atoms in our bodies, they were forged in stars, then scattered across the universe, and somehow ended up, well, as us.
Yeah, it really shows you just how connected everything is. We're all part of this huge cosmic story.
It makes you wonder, right? If the stuff that makes life is all over the universe, could there be other life out there too? Maybe even intelligent life?
Oh, that's the question, isn't it? It's something humans have been thinking about forever, and now with all these exoplanets we're finding, some of them might actually be able to support life. So who knows?
It's crazy to think about what it would mean if we actually found life out there. It would change everything, how we see ourselves, how we see our place in the universe.
Totally. It would be huge, like a total game changer. It would make us rethink, well, pretty much everything.
It's just mind-blowing to think about all the possibilities. But it also makes you appreciate the incredible journey that had to happen for life to appear here on Earth.
Oh, for sure. I mean, our very existence is proof of how all these cosmic forces had to work together over billions of years. It's pretty amazing. And it really shows you how important it is to keep exploring, keep pushing the boundaries of science.
That's so true. So what can we do, as regular people to support that search for answers, to learn more about the universe and our place in it?
Well, there's a lot you can do, like supporting space exploration programs or advocating for more funding for science. Even just staying curious, learning about new discoveries, all that makes a difference.
And I think it's important to get other people excited about science, too, especially younger generations. I mean, you never know. The next big discovery could come from a kid who's just starting to look up at the stars and wonder about it all.
Couldn't agree more. It's all about keeping that sense of wonder alive. We're all explorers in our own way.
Well, I think that about wraps up our deep dive into the universe's most extreme energy events. It's been, well, an incredible journey. I feel like I've learned so much.
It really has been fascinating. We've covered a lot, from those powerful gamma rays and cosmic rays to the incredible supernovae and pulsars, even explored how our own sun came to be. I hope everyone listening has a new appreciation for how amazing, how powerful the universe really is.
And remember, the exploration doesn't have to end here. There's tons of great resources out there for anyone who wants to keep learning: books, documentaries, online courses, other podcasts.
Exactly. Keep asking those questions, keep an open mind, and never stop looking up at those stars. There's a whole universe out there waiting to be explored.
And who knows, maybe we'll uncover even more incredible mysteries in the future. Until next time, keep exploring.